Hello again. The last lesson we were looking at surface waves. This lesson we're going to be looking at electromagnetic waves. Before I go into any more detail, I think I should just explain a little bit about the electric side of the wave, and then later on separately describe the magnetic side of the wave. So I'm going to be explaining basically what electricity is and what magnetism is. If we go back to first principles, we really need to look at the proton and the electron. The electron has a negative charge and the proton has a positive charge. And it's this difference between the two which creates electricity. So this is where the electricity comes from. Now, magnets, it's a different matter. A magnet, let's draw a magnet, has a north and a south component, and it's this north and south component which produces a magnetic field. And this is called a magnetic field. Now, most of the time electricity and magnetism are related. For example, if we have a magnetic wave, let's just draw some sort of magnetic wave here. Okay, so, or magnetic field, I should say. Let's say we have a magnetic field. Okay, so that's what you feel outside the magnet. Okay? And then you have a wire. Try and draw a wire here. And we move the wire through the magnetic field, something like this. Then through the wire, while the wire is moving through the magnetic field, we're going to create a current. So let me just repeat that again. If we move a wire through a magnetic field, we can create a current. Now, another way we can create a current or create electricity is by moving the electric field. So we could in fact move the electric field and we could keep the wire stationary. We could keep the wire in the same place, and that would also produce a current. So let's label this current. Let's call this positive over here and negative over here. Okay, I mean it could be the other way around, but just for the sake of labeling it. Okay, so that's a simple way to make electricity. Let's have a look at how we can make a magnetic field. Now let's take the same piece of wire again. Now let's make it red. Okay, but this time we pass a current through the wire. So here's the current, and the current is going through the wire like this. Now this current will interestingly create a magnetic field. So let me try and draw this magnetic field. Let's try and make this a little bit clearer. And the magnetic field is traveling around the wire. The magnetic field goes around the wire whilst the current goes through the wire. So again, let's label the charges. Call this positive here, and we'll call this negative here. So just to repeat, the way we make a magnetic field, a simple way to make a magnetic field, is just to let a current or electricity pass through a wire, and it will create a magnetic field around the wire. So we can see that there is a direct relationship between electricity and magnetism. Yeah. An electric current will create a magnetic field, and a magnetic field will create an electric field. So next, let me see if I can give you some examples of in real life of how electricity can create a magnetic field and how a magnetic field can create an electric field. Let's take, for example, a motor. Excuse my art, but let's see how we go here. Something like okay, so this is the outside of the motor. And this part here is the rotor. So as you know, a motor needs electricity. So let's put some wires going in here, and this is the electricity. This is positive, this is negative. So if you put electricity into the rotor, of course, will turn. The rotor's going to turn around, right? So you put electricity into the motor and the rotor will turn around, and we call that a motor. Now on the other hand, if we were to turn this rotor, if we were to rotate this rotor, yeah, the rotating rotor would move electric coils through a magnetic field, which would actually make electricity. And we would call that a generator, because the movement of the rotor creates electricity. So let's just write generator here. Generator. And let me give you some examples of where we might find motors in real life. For example, the lift. Yes, when you take the lift to go up to your flat in your apartment, yeah, that's powered by a motor. What else? A crane. Yes, a crane to lift things, for example, onto a ship. And let's think of an example for a generator. Oh, I know. On your bicycle, of course. On your bike, yeah. Your lights are powered by a little generator. We actually call it a dynamo, but it's exactly the same as a generator, which rubs up against the tire on your wheel. So as the wheel goes around, it turns the shaft, and the shaft creates the electricity, which power your lights. Okay, so next lesson we're going to actually have a look a little bit more between this relationship between magnetism and electricity. I'll explain how a electromagnetic wave is created. For example, light or heat, radiation. Okay, see you next lesson.